we created a model which transformed a stack of circles into kind of broken ways, and we can manipulate this number of points, like how many broken points this vase has, and we can change radius, we can change number of circles, etc. So it's a very flexible model. Today, what I want to do, I want to review data flow. So how data flows from basically, if we do it visually, from the left side from the model, from the sources to the end of our data generation algorithm, and how it transforms along the way. Let's start with let's start from left side. Here we have our data sliders. And our data sliders are our parameters for this algorithm. Let's look at what a data slider is for Grasshopper. So to look into the data, we use a panel element. So, and if we feed data slider to this panel element, we will see that it's actually we expect that it's just one number, right? And we vary this number changing the slider position. But what actually, but we see that in this panel, it's not just one number. We also have here an index, and we also have here something which we have barely dealt with before. So what's that? Okay, first of all, it is not just one number, it's a list. So as we already mentioned it before, that everything in Grasshopper is actually a list. And if it's just one number, then it's just a list with one number, like with one item on the list. And as we remember, list indexes start with 0. So this list has just one item, and the value exactly it's specified by the slider position, right? So, and the index of this value is 0, because all lists start with index 0. Then it's a question what this is. And actually what it is a sign that actually Grasshopper operates not with lists, it operates with lists of lists. And Grasshopper calls it data trees. So for many, the problem is many Grasshopper components, they will produce not just one list, but several lists. And somehow these several lists should flow down the model and be processed down the road, right? So how Grasshopper will distinguish between them? So what Grasshopper does, it organizes the lists in data trees, and a data tree basically it's a list of lists. What I mean here, I will try to illustrate. We will look at it closer down the road. But basically the idea is, if so when we discussed how a Grasshopper component processes inputs if both inputs are lists, right? So we basically just imagine that one list is fed to one input, another list is fed to another input. These lists have different number of items, and then we illustrated how first time this component runs on elements 0 of both lists. Next time it runs on elements. Just a moment, I should be able to move it. But sorry, but yeah, element 1, and then element 2, and if one list is longer, then the last element of a shorter list will be like duplicated, duplicated in the next position. So that's how lists are processed, and that's what lists are. Now, if we have more than one, if data flow requires several lists simultaneously going along one line, how it will look like? Basically, it will be, I would call it also a list. Grasshopper developer prefers to call it a tree. It is basically, from my point of view, it's a list of lists. So, and this list of lists, it has a little bit more complex index. So instead of saying that first element is index 0, second element, which is list, index 1, etc., Grasshopper wants to confuse you less. They say, okay, data trees are more complex. So they're more complex. So then when a list is first element, it has an index. And this index, it's a sequence of numbers separated by semicolons. And this set of numbers, uniquely identifies a particular element of a tree. So basically, for example, we have several lists. For some reason, during our algorithm, several lists have been generated by some elements, by some element. And this element will output what's called data tree. First list will have some index. Second element will have also some index, but it will be different. Usually it varies, like the last digit, we will see that the last digit varies. So, and next element will have like next index, etc., right? So, and it will allow us in the future reference particular element if we need to reference a particular element from the list. Elements of data tree, not surprisingly, they called branches, and basically each branch is a list. Lists in data tree are completely independent, and just each of them uniquely identified by this set of numbers, and number of numbers in this list can be very different. So it can be just one number, it can be like whatever, like any number of numbers, and basically even what numbers are chosen is not limited. So it's a very general data structure. Now let's go back to our Grasshopper current Grasshopper generation algorithm. So this slider, it outputs a very simple data tree. This data tree has only one list element, one branch. This branch is identified by index 0, and it has only one, and this list, as each branch is a list, this list has only one element with index 0. And if we look at any slider, we will see the same thing. We'll see that it's just one number. It's a list with one element, index 0, and then all of them like in their data tree, they have index 0 because it's the default for Grasshopper. Let's see what will happen next. So now let's take our next element. Now, our next element is data range. What it does, it takes a domain of numbers from 0 to 215 in our case, right? And then it splits it in a particular number, basically generating particular number of integers. No, not integers, floating, real, like real numbers. According to this slider, right? Let's look at the output. So it's 10 locally defined values, and they go from 0 to 2015, right? So yeah, with equal steps, right? Let's see what data structure is generated by this element. So this element generates a list. So for this, for this input, it generates a list. This list has 10 elements because the whole domain, like the whole range, is split in 9 sections plus one like beginning value and then 9 after it. So overall 10. And this data, and it is just one branch. It was one branch. Now it's one branch. And the index of this branch is 0, 0. So now our question is, for what purpose? Like, why Grasshopper change? What's the logic? Like, it was index 0 for the slider. Why now it becomes index 0, 0? Let's see. For example, we have another, just a moment, another data slider. I want it to be lower. Otherwise, just a moment. I want to give it lower, like to start from 1, for example. Okay. So, and this data slider we will set it to 2, just in case, and we will feed it into the number range, right? So what happens now? Now we have, like, for the domain, we have the same domain, but now we have 2 numbers. So we requested this domain to be split once in one iteration in 2 sections, in another iteration, in another iteration in 9 sections. What the Grasshopper does in this case, it runs this component twice. And then the component generates 2 lists, right? Grasshopper needs to organize them somehow. And what it does, it generates a more complex data tree with 2 branches. So our and first branch has index 0. First 0 comes from previous from the elements which were parameters for this range, for this range element. And second index comes, like, Grasshopper numbers output lists, like produced results. So 2 lists were produced, 1 for 9, 1 for 2, right? And index for one of them is 0, 0, index for the other one is 0, 1. So now, down the road, if we need to distinct what particular generated list we want to work with, we potentially can say, okay, we want list with index 0, 1, list or branch, right? And then we will work with this data. Okay, now we do not we do not need this now. Let's come back to our normal model. Okay. What this element does, it takes two elements, domain and number, and generates a list from it. So there are objects which there are Grasshopper elements which produce for single items, they produce list results, and range is a good example. So we provide just one input for one value for each input, and as a result, this input produces a list. So multiple items. It's what they call one-to-many relationships. You see the name of this output is range R as list. So it shows us that the result, the output of this element is list, is one list, or if we have many inputs, then it will be a list of lists or a data tree. Next element, this element just creates a vector. It creates a vector in z direction. You can see it's unit z. So it takes each number, multiplies it to the vector, z direction vector, and what it does, it shifts basically in the future. It will shift our circle, a generated circle, up above level 0 along the axis, zx. And this element, if we look at it, what we see that now, yes, it's still a list. It still has 10 elements because for each input, one output is produced, right? And there was no change in the index of the branch, in the index of the list, because actually this element is one-to-one element. There is no change in the amount of data in and out, and our data flow just continues without. From Grasshopper point of view, Grasshopper just processed input values and produced some resulting values one-to-one, and data element hasn't changed. And now we come to a moment when we want to produce our circles. Circle element takes two inputs. One of them is a plane where the circle will be created. The other one is radius. So we know that for the plane, we already have a list of basically of base point of the planes. And these points are, as you can see here, they just evenly spread from the world origin to 0, 0, 215, right? So this is where our circles will be located. And also by this time we generated a list of radiuses. We generated it using this element, a very interesting element called graph mapper, which basically allows us to map numbers to use a function mapping numbers to values specified by the graph. For example, if I want to show it to net. For example, if you can see that this shape of these circles, it reminds of this graph. And if we change the graph, if we change the graph, it will change radiuses of the circles. Also, we can change, and as this graph is Bezier curve, so we can control location of the points and the curvature. So, and it allows us to play with forms like very efficiently. And this element, so this element chain allowed us to form a very similarly looking list. So it's a list of 10 numbers, which we'll take as radiuses. And it's also a list, and this list is also, it has the same index. So because all data flow between elements goes through data trees. So it's also a simple data tree with the same 0, index. So let's see what our output from this circle element is. This circle element has basically 2 lists as inputs, and the number of elements is equal between lists. So it also maps elements 1 to 1. Like it takes 2 elements and then it produces one element from them. So there is no multiplication, there is no one-to-many relationship. If we check the circle, we do not see any list or data tree descriptions. So that's why the tree, which is a tree which we can describe as an input, the output tree will look very similar. So it's just one list with 10 items, and index of this list remain the same. And now we come to a more complex element, which will shatter the circle. So when it shatters the circle, it takes the circle, it takes number of elements we want to shatter this circle, number of segments we want to shatter this circle into, and then it will produce several elements. Like for each circle, several segments will be produced, several curves. So, and obviously will be a list. So let's see how it works. Okay, now we see that our model, our list became more complex. Grasshopper decided that it needed to add another index. So now it's not a 2-end index data tree. It's not a 2-number index data tree. It's a 3-number index data tree. And why it was needed? It was needed to allow us to track all the circles. So basically, first circle produced 3 curves, and it is a list with 3 curves. and the index assigned is 0, 0, 0. 0, 0 is taken from the data tree, which is the input. Next element is produced from the second circle, the circle which had list index 1. So, and then it produced also a list, and this list also presented in this data tree, like it's in next list, and it takes next possible index 0, 0, 1. And for each next circle, next index is taken. We can play with this a bit. For example, here, if we take at the, if we look at the circle element and the list which it produces, so we can this is like what goes down to the shutter element is a data tree, and we can transform it a little bit. For example, data tree, the most efficient element in data tree transformation is called path mapper. Let's see what we can do. So if we feed this output of the circle element to data mapper, and we feed the output of data mapper to the shutter element. So what we can do, this element allows us to transform indexing. For example, so now our circle, the data tree produced by the circle element is very simple. It's 0, 0. It has only one branch, 0, 0. I want to renumber this. I want to assign a different index to this element. Just a moment, I want to So here I describe the index which I have now. It's a 2 numbers index. And on the right side, I will describe what kind of index I want to have for this element. And as I have only one branch, I can do it very easily. I will say that, okay, I want my index to be 0, 1. Let's see how it will look. You see, the list itself remained the same, but then the number, like the index of this list is changed. So this element transformed the tree, and basically list elements are not affected. List remains the same, but we just changed the index number. Sometimes we need to do that. Now we're doing it just for to educate ourselves. Now let's see how it affected the shutter element. You can see in the data tree produced by the shutter element, first 2 indexes, they were 0, 0. Now there's 0, 1. Because shutter element wants to kind of remember the history. It wants to give us a sense that this this list of curves was produced from some circle which had was in a branch indexed 0, 1. So we can kind of trace, this index allows us kind of trace the data flow. So, and as before the data flow was was characterized by index 0, 0 in data tree. Now we change this index, now it's 0, 1, and shutter element changed indexing of the output accordingly. So if, for example, we need to for some reason, we want to extract curves for like second curve, right? Second curve, as indexes start with 0, second curve will have 0, index 1, and then we can basically, if we take a 3 element with an index starting with 0, 1, no, it's not, I'm not correct there, sorry. It's no, this last index will characterize the circle, a particular circle. This is just, let's take it just an exercise. These two numbers will be meaningful if we have another set of circles. So if this element, for example, we feed another list of radiuses or another list of planes, then this element will produce a data tree with 0, 0 index and 0, 1 index. And then we will distinguish between these two stacks. But basically what I wanted to show you, that this element takes the index from the input element and adds one additional index to indicate that there are more items going down the road. Okay, let's go back to our circle. Okay. Okay, now at this point, yes, that's what the shutter element produces. Basically, it splits the circle into segments. Now it's like 3 segments for each circle. And this element just allows us to show what we have. We have this endpoints. Like for each curve, this element generates endpoints. So for each circle, now we have 3 like breaking points. Okay, that's where we are now. Let me just, if, for example, just let me think what I can do. Yes, okay. Now let's look what's going on in our model further. We like next step is to move our geometry. So basically we take the curves for each circle and we move them a little bit. So just to create this breaking points. We take the the data produced by shutter element, and it's a data tree, right? And then we apply motion, like we apply some transformation to it. Basically, we move it, right, to a specified vector. This element, it also it's also, I think, 1-to-1 element. It would be my guess. Let's see how it affects index. Yes, you see, index remains the same. So 3, it still has 3 indexes. So it means that basically this element also 1-to-1 element, and it didn't affect any indexing. But now let's look at how we created the movement. So for this shutter element, we wanted to generate, we wanted to move shutter element, created our split our circles into curves, and then we want to move each curve a little bit. How did we do it? So we used an element which allowed us to extract from this data tree. We extracted one branch and we characterized this branch by its index. And it's a normal thing to do in Grasshopper. So we were able to select, like, this is our data structure which is coming to this tree branch element, right? And we were able to select a particular item or a particular branch of this data tree, which is a list, just to select it, specifying its index. And then what we did, we extracted endpoints. Let's see. So this element produced just it produced just one branch tree with still index remains the same level index, and it's the index of the extracted branch. If we use another path here, if we want to extract branch 001, right? Yeah, then it will be index of the branch will be here. But this data tree, it's significantly simplified in comparison with the input data tree because only one branch is present. Okay, now we have this basic list of curves, and it goes into this curve element, and this curve element doesn't multiply anything, I believe. Will it? Yeah, so the index of the branch remains the same, just elements of the list are being processed. So now we have two lists, one list of a starting point, the other list is a list of ending point. Okay, and we fed it into an element which will create a vector. So this vector element also one-to-one, and we see it doesn't produce a list. And we expect that index won't change. Index remains the same, data tree remains the same. And next step is just to multiply this vector to allow us to change the length of the vector. So basically how far this curve will be moved. So, and this element is also one-to-one element, and so it won't change the structure of the tree. Now we have, and now, okay, what it does to what this element does to our model, if we change this number slider, then the gap between curves will be changed according to the number we specified. So now we are back to our geometry move element. Let's once again look at the parameters which are fed to this element. First parameter is a data tree with how many branches? With 10 branches. So from 000 to 009. And the second and the other input is a list of vectors with yeah, it's just a vector. Sorry, it's not. Is it? No, it's a list of vector, and each vector specifies how to move a particular curve. So if we look at the data tree which is going down the road from the shutter element, each list has 3 curves, and we need to specify a vector, like how we move a particular curve. So now, for move element, we have data tree as one input and a list as another input. How data tree and a list will work together, in how they will be processed together in a Grasshopper element. It's very similar to the logic which was applied to lists. So basically, each branch will be taken and merged with a branch of a data tree in other inputs, right? So and first branch will be merged with the first branch of the data tree, like, and all branches are sorted. So you can see that basically these indexes, they're always organized from lowest numbers to biggest numbers. So they're always sorted. So elements with where first number is 0 will go first. If this element is just 0, it will be the first one, like the very top one. And then the next index goes also sorted, then next index also sorted. So there is a indexes, they define a sequence of lists in a data tree. So they're always organized. Basically, in a list, it's a little bit simpler because it goes from 0 to some number without any gaps. For a tree, it's a little bit more like, I wouldn't say vague, but it's a little bit more flexible. So we always can say if one index number going after should be after the other one, because we just start comparing first number, this first number. If one number is lower, then the index with lower number goes first. If they equal, then we can compare next number. And the fact that each index is unique, it basically guarantees that we always, like, one of them will always be lower, one of them will always be bigger. So and then we match branches. In our case, one tree has 10 branches, the other tree has only 1 branch. So then it's exactly is as in lists. Then just this 1 branch will be used to match each branch in there. It will be matched with the first branch. And then for the second branch, as there is no other branches, the same branch will be used, then the same branch will be used, the same branch will be used. So basically here we have what does it mean to have a relationship tree to list? It's basically tree to tree, because everything is a tree, but one tree has only one list. So, and then it just each list in one in our geometry input will be matched with this list. And as a list, all the lists have 3 elements, it's an easy match, 1-to-1. So, and each of our curves will be moved to the specified distance. So let's, yeah, this is how it will look like. What we do next? Next, we want to create interconnections between these curves. So we want to connect ends, and then later on we will join them and run pipes along each broken circle. So For this, we use this element. First, we generate ends. And again, curve start end element won't transform the data structure. We have seen that. So basically, it will be very similar data structure with similar indexes. Only data elements will be changed. And what we do next? So next, we want to create lines, right? So we want to create lines connecting our points produced by start and end elements. So basically, but if we take these points right away from this element, then start and end of each curve will be interconnected, and it's not exactly what we want. We want lines between start of one curve and end of the next curve. So that's why we use this shift list element, which basically what it does, it takes endpoints and change the sequence and what's called shifts them a bit. Let's see how it works. So this is our endpoints of our curves, right? And what we do here, we take this list. You see, this parameter is described as a list because it's important. This element, it processes lists. So that's why this parameter, it takes a list as a parameter. Then we specify that we want to shift the list. So basically, we want to shift elements, changing their position on the list. And wrap, it's set to true in our case because we want the element which goes out of the list, we want to go it at the back of the list. So let's see how it works. For example, here, like it's easier to see if we have two panels, one panel, and let's use another panel here. Okay, let's compare. So what we had a point and end point, minus 20, 31, 0. And now this point becomes like it had index 0. Now it has index 1. The next point was minus 17, minus 33, 0. And now it has index 2. So basically, these 2 points, they were shifted down. And the third point, which 3720, right? It also was shifted down, but it's like was pushed out of the list and it went to the first position because it was wrapped. So and now this 3720, it becomes first element, and it was done with each list, with each branch of the data tree. So all the branches were processed, like basically all the lists on this data tree were processed the same way. So, and what it did, it changed the order of endpoints, right? So now the order is different, and when these points come to our line element, now start points will match. Okay, just one second. So this is right. Sorry, I want to make it a little bit clear. Yeah. So, for example, elements 0, 0, 0, 0, 0, like first list, and first list in our data tree of starting point, and first element on our data tree of endpoints. They are, you can see that they have different indexes, but it doesn't matter. We match them one by one. So the first elements of our data tree, they're matched. So before, endpoints were in the order of in the same order, like for each curve, like endpoints were endpoints of the same curve. Now these are endpoints, like position 0 is an endpoint of a different curve, right? And our line element connects. When we connect the line, we find that, okay, now we find a perfect match, and basically start point of one curve matches with end point of the next curve, and basically it creates our interconnections. Now, why our indexes become become longer in our data endpoint data trees? We can see that this element produces lists, and for now we produced just for each list we produced one list. But for example, if we specify for shift, if we specify 2 values, not just one, then this last index will be used. For example, we will shift twice. So one time with shift -1, second time with shift 1. And you can see that now each list of endpoints produces 2 different lists. You see, first time it was shifted as before, like 37 minus 20, 17. And next time it was shifted in the different direction. So basically, let me show it quickly. So this is our first list of endpoints, minus 20, minus 10, 20, minus 17, 37, it's the initial position. First time we shifted it -1, so in one direction, and it switched, it shifted everything down. So -20 became element 2, -17 became position 2 or index 1, -17 became position 3 or index 2, and the last element shifted to position 0. Now, next list produced from the same list. So this second shift value was applied. So, and basically our first element, -20, was shifted up, like everything was shifted up. So -20 was shifted up. It should be dropped from the list, but as a wrap is on, it just goes to the bottom. It becomes the last element, and 2 others, they just go 1 position up in the list. So and we see now, we see that this last element is useful. Like even if we have only, if we shift only by 1 number using 1 index, even in this case, we potentially want to have this opportunity. If we change our mind in the future, if we want in the future, for some reason, we want to use 2 shifts, we do not want to change our data structure to be dramatically changed. That's why this position will be taken anyway, and number of indexes will increase anyway. So now we went to lines, and our interconnecting lines have been created. Let's see what happened with our with our data structure. So we see that the most complex index, like four value index, was inherited. And now we have, instead of a data tree filled with points, we have a data tree filled with generated lines. And again, it was a very simple match. Just each branch was matched sequentially. Like first branch here was matched the first branch for this from this data tree, etc., etc. And as number of branches is actually identical, so they all matched and all lines were have been properly created. So, and now we wanted to join, first we want to merge our curves, creating, like putting, like, let's see how what happens here. You see here, each list, each branch in our data tree, each list includes all related curves and all interconnected lines. So how did it happen? Basically, this merge element, we fed all curves from our geometry move element, and we also fed lines into these elements, and then it matched indexes, like branches with identical indexes. It just merged the lists under identically named branches. But you remember that here we had a list with 4 indexes. We didn't use the last index, actually. It was always 0, but indexes were different in comparison with different of our geometry. And that's why the merge element wouldn't work. Let's see what would happen if we take this merge element and if we feed output of line element. You see, nothing matches. We have, in this data tree, we have exactly what we asked for. We asked just to merge data trees, but our data trees do not have branches with identical indexes. So they, like, we have just a data tree which has all branches from our line data tree and from our geometry move data tree. This is exactly what we do not want. We want to match our lines with curves which produced them. So we needed to eliminate this last index because it was like we basically didn't need it, and we used this universal path mapper element. So we just specified that we initially what we initially had, the source had 4 numbers, and we just specified that our target, like resulting indexes, should have only 3 first numbers. We basically dropped the last number. And after that, because last number wasn't informative, it was always 0. After that, basically, our data tree, it was just like the index, like index we didn't need was dropped. So, and then our indexes matched related indexes in our geometry tree. And then our merge element produced exactly what we wanted. So, and what was good about it, that now the output was perfect to feed into join curves element. And join curves element just took each of the lists and produced a curve from it. So one curve per data tree or from all curves in data tree branch. So now our question, now just a moment. So I want to see. So here we have three indexes. So now my question would be why join curves element added another index. And my guess would be that actually a set of curves can produce not just one element. It can produce, like we were lucky. So we supplied all curves needed to create one curve from our set of curves. But potentially it can be not one curve, potentially it can be just several curves if it's impossible to join them all in one curve, right? And probably in this case, this last index will be used, and that's why Grasshopper added it. And our next and last element in this data generation algorithm is pipe element. And this pipe element just runs a pipe along each curve, creating this like more like wire-like broken ways. And you see that another index has been added, of course, because we can supply several different radiuses, and then for each radius, several branches will be generated for each curve. So that's how we so that's conclude our research, our like exploration of data flow through this algorithm. And yeah, it's already 1 hour and 15 minutes. Okay, and I would say that exploring it, we almost touched all aspects of data flow in Grasshopper. And basically, I hope that now you have kind of idea how to research data flow and how possibly you will need to modify data flow a little bit in your Grasshopper algorithms to match branches in data tree if it's needed.